2020 question 10. A student is asked to memorize a long list of digits just because, and then write down the list sometime later. The proportion P of the digits recalled after T hours can be modeled by this function. P of T is equal to 0.82 minus 0.12 by the natural log of T plus 1. Part A, find the proportion of digits recalled after 3 hours according to this model. Just looking for P of 3. Just calculator use, 0.82 minus 0.12 by the natural log of 3 plus 1, if you want to put it in like that. On a calculator, this is giving me 0.6536. So 0.65, 65% about of the digits recalled after 3 hours. Part B, after how many hours? Well, exactly 55%. So when will this function, I'll do it here, when will 0.82 minus 0.12 by the natural log of T plus 1, when will this equal 0.55? So if I bring this guy to the right, it'll be positive, so I'm bringing the 0.55 to the left, so they'll both be positive, so I'll have 0.12 natural log of T plus 1 on the left. If you imagine it's on the left or right, on the right, 82 minus 55, 0.27. So we'll have divide by 0.12, we'll get the natural log of T plus 1 is equal to 0.27 over 0.12, but that's the same as 27 over 12, so I'll just get rid of the zeros. 27 over 12. So your rules of indices, e to the power of 27 over 12 is equal to T plus 1. So T should be equal to e to the power of 27 over 12 minus 1, which is giving me 8.487. This is in hours, 2 decimal places, 8.49 hours. You'll remember 55% of the digits. Part C, we're asked to find P prime 1. Let's just write P prime T again. 0.82 minus 0.12 by the natural log of T plus 1. Have to differentiate the natural log of x goes to 1 over x. Maybe it's one of those you recall. So P prime T is going to be equal to minus 0.12 by 1 over x, or 1 over T plus 1, which is equal to, we're looking for P prime 1. So we're going to get 0.12 minus over 2, which is equal to minus 0.06 for P prime 1. P prime T is always negative between 0 and 12. What does this tell you about the proportion of digits recalled after T hours? I'm just going to do a quick table. You'd have time in exam between 0 and 12 here. Let's see what this function looks like. So here's a table between 0 and 12. After time equals 0, we'd be expected to memorize 82% initially. And then you can see it's declining all the way down. So what's this telling us about memory? As time goes on, our memory decreases, is what this function is kind of showing us here. And I'm just throwing in at the bottom, after 130 hours, if you don't do any study for a weekish, your memory declines significantly to 24%. So get preparing for your next exam. So what does this tell us? I think that's probably enough. You could draw the model. It's an exponential. It's going to decrease, isn't it, over time like this? Exponentially. We could draw a little x and y axis if you want with your initial amount of 82. And show it decreasing over time. And then in part D, use calculus to show y is equal to pt. It has no points of inflection, so points of inflection we'd have to show that it's equal to 0. P prime prime t, or p double differentiate t, whatever way you like to say it. So we had P prime t was equal to minus 0.12 over T plus 1. Don't panic at these. This is equal to minus 0.12 by T plus 1 to the power of minus 1. So now we can differentiate it by using our rules of indices, or to bring the power, multiply the power by the number in front. So that's going to be a minus by a minus 0.12. And that's going to be then t plus 1 reduced to power minus 2. So that will give 0.12 over t plus 1 to be squared, which is a positive over a positive, and it can never be equal to 0 anyway, not equal to 0. Therefore, no points of inflection. Write the whole thing out in the exam. So continuing with the mode in this question of you need to study. If we learn a skill and don't practice it, how well we can do it usually decreases over time. For example, if you learn to play the guitar and you don't play for a number of months, you will probably not be as good as playing the guitar the first time you try it. This effect can be modeled using the following equation. Y is equal to AE to the power of BT again, this kind of initial amount. AE to the power of BT is what we've seen before, but we just have, in this case, just T plus 1 in here. So it's something similar. Write C in terms of log to the base 10. Well, that's what we normally write our logs. We just don't show the 10. So we just want to manipulate this formula to get C on its own. So I'm going to divide by B. A over B is equal to T plus 1 to the power of C. So then if I get the log of both sides, I can get the log of A over B is equal to C times the log of T plus 1. The division of log is a minus, so the log of A minus the log of B, if I can write it properly, is equal to C times the log of T plus 1. I'm just going to put the 10s in. That's what they want you to show. 10, 10. And then if I want C on its own, I have to divide the left hand side by the log of 10, T plus 1 to the base 10. Log A minus log B over log T plus 1 should be equal to C here. That's part E, part 1. And the last part of this question, a student got 80% on a guitar exam. After 2 years of not playing, the student got 47% on the same exam. Use this to find the value of C. Correct 3DP. So just double check what we were told initially. There's a little trick in here. I think we're dealing with months, aren't we? And they've given us years below. T months later. 2 years. 2 by 12 is equal to 24. Make sure you were concentrating at the end of the paper. So A is how well it can be done. So that's the 80%. B is the 47%. And we have T as 24. Okay, well, we can just fill that into the formula that we've just used. So the log, we know they're all to the base 10. The log of 0.8 is the 80%. Minus, how good are you now? You're 47%. How many months later? 24. But you're going to have to add 1 based on our formula. Is going to give you a value for C. And if I type this into a calculator, it's giving me 0.1652. Correct the 3 decimal places. 0.165 is equal to C.